The transportation all-terrain, ATST, also known as the walking chicken due to the shape of its two extremities, is a character from the Star Wars universe, who was used mainly as a weapon of war. His first appearance was during the Battle of Hoth Star Wars Episode 5. In 1980, when the movie was released, it spent 8 weeks as the highest grossing. These films have collected more than $9 million since their debut in 1977. Star Wars has generated more than $10 million in tackling at a global level. In terms of age, 29% of the viewers of Star Wars are between 18 and 29 years old, while 28% have between 30 and 44 years old. Most of the viewers of Star Wars mainly watch the films, but there's also a significant percentage that enjoys the series and the books. 2. Movement characterization. The ATST presents two types of movement. The first is a partial rotation of approximately 45 degrees with respect to axis Z, which allows you to move the extremities and simulate a movement. Because of this movement, the ATST will perform a vertical translation in the axis Y. The second is a rotation of 180 degrees with respect to the axis Y, which generates a turn in the head of the ATST. The EWC performs a movement with respect to the axis Y of approximately 3 mm to simulate the rise and fall of the character. Design and construction of the gears. During the fabrication of the gears, the space was considered, primarily, the space available for the mechanism. The primitive radio was determined and a relation was established between the gears due to the limitation of the space and to maintain the same velocity. Then the nominal diameter, the step, the angle of the pressure, and the number of required denders were determined. All these parameters were taken into account for the fabrication of the gears using the SolidWorks software. To ensure the compatibility between the Da Vinci gear and the gear that was to be attached, it was decided to use 6 cylinders distributed at 60 degrees of separation and located at a distance of 1.8 cm of the center of the gear. This configuration allowed to reduce the speed of the rotation and reduce the speed of the gear, which in turn reduces the wear and increase the durability of the system. In addition, it was considered that the location of the cylinders should avoid interference with other elements and guarantee the correct functioning of the gear. Manufacturing of the components. For the fabrication of the different components, a process design was implemented through the SolidWorks program. Design of the box was sent to a laser cutter to obtain the final piece. For the lever, the gears and the supports were used for the 3D impression. As for the additional elements, such as the axes and the cylinders located in the Da Vinci gear, they acquired wooden bars with the dimensions required. It's possible to observe that the mechanism was simulated and the result obtained presents a similar function. However, during the assembly of the mechanism of the gears, it was identified that the axes of the 3 gears could not be located in a parallel manner due to limitations in space. As a solution, the low gear was lifted a few centimeters above the plan, always ensuring their contact with the other 2 gears.